Hi guys, so this will be the problem solving session, but today here I will solve two problems which are very different and have been asked few times. There is a separate concept for this. There is nothing called as formula here. Just using these two problems I will be giving you an idea about how to solve these kind of problems. So first problem will be, determine the total change in the length of a bar of constant cross section having a hanging vertically and subjected to its own weight as the only load. Take W as its weight density. Something they have given weight density, which is nothing but weight of the object by volume, and is also expressed as rho into G. Okay, you can now pause the video and try to solve it. Alright guys, so I am going to solve that question now. So first step in every problem, make a neat sketch. This is a bar which is hanging. Length of the bar is L, hanging, and the weight of the bar is acting downwards. We have to find delta L due to this weight, its self weight, okay, for this bar. Now in this case we know, okay, I have chosen this formula for a reason. Why? Because delta L we have to find something. We know here length, we know some load. So this, I have not chosen this formula. This is also a formula, right, for delta L alpha delta T, but there is no temperature and all in this case, so I have not chosen this. So selection of formula is also important. Now here the way we have weight density is weight by volume, total weight. This weight is nothing but load itself, okay. So load can be written as volume into weight density, okay. So this I will write as weight density into volume into L by AE, correct. Now volume can be written as area into length. Area will get cancelled, length will become square. So weight density square by E. Alright, now this is nothing but change in length, okay. Now you know the weight density will keep on varying as we move up. It will keep on increasing. See, the volume at this point will be only this much, but the volume at this point will be this much. It goes on increasing as we move up. Weight density is a function of volume, right? The volume will keep on increasing as we move up. So the weight density, now as it is changing, we have to integrate it. Taking an element, say dy, at a distance of y from here, and if we integrate it from 0 to L, we will get the answer for change in length, right? Now small, for this element, if we want the change in length, we are taking a differential change in length similar to the previous problems how we have done. So even here this will become like this. Yeah, area into length will give you volume. Length is y, it keeps on varying from here to here. Dy is the length of the small element which we will integrate to get delta L. AE is constant, A cancels, W by E, we have y square by 2. From 0 to L will give you change in length. So we will get the final answer as delta L. Yeah, this is the answer. Now similarly I'll solve one more problem. Okay, I hope you got this concept. We have to substitute the load. We have to substitute the load in terms of weight density into volume, and then the volume may be written as A into L. Now as the weight density keeps on varying, so we have to substitute in forms of differentials, taking a small element and integrating over the length. Okay, similarly I'll solve one more problem just to get a hang of it. Find delta L due to its own weight for a conical bar whose base radius is r. The bar is hanging vertically about its base. Okay, it is a simple problem, but only the change is the shape is changed to conical. Yeah, now I want you to pause the video and try to solve it using the same concept. Alright guys, so we will solve it now. The first step being make a proper diagram. This will be the shape of it, right? Now here it's a point, so radius in this case is 0. Here they have already given the radius as r. Okay, we take as small r. Small r is a function which varies over the length L. Yeah, now using straight line we can find out the equation with which the radius is varying. I want you to try it out guys. If you have doubt, just comment it in the comment box. Okay, we will get it like this. R is varying with y. Okay, y is taken from the bottom. Okay, now we need to find the change in length, right? Change in length is nothing but PL by AE. Okay, now taking a small element dy, the small change in length, differential element of delta L will become weight density into volume, which will be substitution for P into L by AE. Now L will become dy, volume will become area into y. Correct? Now one more thing to keep in mind, this is a cone, so is this correct? Of course not. The volume for cone you know as 1 by 3 pi r square h. Okay, so this is wrong. You can't do this. This is only for rectangular bars. Okay, in that case the formula will be, the concept will be same, but the formula will slightly change. It will become 1 by 3 pi small r, which is a varying function of y. It will be small r, which is ry by L whole square into h. H is y distance into dy by AE. Correct? I hope you got this. Pretty simple. Only the volume formula has changed. Rest all is the same. Now just pure integration. After integration you will get it as change in length is WL square by 6E. I suggest you remember this as well as the previous formula. Okay, for square, for triangle, that is a conical. You have to remember these two because they might ask it for 1 mark question. In that case you don't need to integrate in the exam and solve it. Otherwise you can always solve and check if you are not sure about it. Thank you guys. This will be the last topic in this chapter. From next video onwards we will start with a new chapter called as shear stresses on the block. Please do subscribe to my channel for getting more information about GATE and further getting new concepts.